Analysis of isolated and non-isolated Zeta converter based on battery charger. Abstract conventional battery chargers are due to the nonlinear nature of a diode-bridge rectifier used for the AC-DC conversion. A single-phase non-isolated Zeta converter topology is designed and implemented for charging a 100 Ah 48V lead-acid battery. The challenges of non-isolated Zeta converter topology is reduced heat loss and smooth charge of battery. The simulation results shows that THD of the input current is low as compared to isolated Zeta converter. The proposed converter is controlled using the sliding mode controller, SMC. By proper tuning, the controller changes the charging mode from constant current to constant voltage. The analysis between the isolated and non-isolated battery shows that the non-isolated battery charger can achieve the increasing the state of charge and smooth charging. Italics mode. 1. Introduction. The major concerns with the conventional vehicles are the phenomenal hike in conventional fuel prices as well as public health issues. EV are constantly influencing the modern transportation system paid to their energy-saving mechanism and reduce the pollution in the environment. The lead-acid batteries are normally used for heavy-duty operations involving many hundreds of amps. To charge these batteries we specifically need chargers rated to HON-DLE high ampere charging levels for long periods of time. The high-power lead-acid battery used for charging large high-current lead-acid batteries in the order of 100 to 500 Ah once the battery gets fully charged. Through non-isolated Zeta converter is similar to that of a buck/boost converter. It has an advantages of non-inverted output. It has a wider range of duty ratio than any other converter. The converter exhibit improved power factor, low input current distortion, low output current ripple and wide output power range 11. A non-isolated Zeta converter is fourth-order DC-DC converter capable of amplifying and reducing the input voltage levels without inverting the polarity. The SOC is defined as the percentage of the remained charge inside the battery of the full charge, which is one of the most important parameter on batteries. IJERT SOC estimation owns a grade of significant to the vehicle. Its estimation is a key research area and it should be exploited within designed limits. Common SOC estimations are current integration method, OpenCIR quit voltage method, discharge test method, resistance prediction method. The non-isolated Zeta converter is operated in discontinuous conduction mode, so it reduces the diode reverse recovery time and zero current switching. The low transformer is not presented, so the system weight and losses are reduced and also improve the efficiency. The sliding mode controller, SMC, is a nonlinear control method that alters the dynamics of a nonlinear system by application of a discontinuous control signal that forces the system to slide along across of the system's normal behavior. Figure 1, Proposed System Block Diagram. 2. Proposed non-isolated Zeta converter configuration and operation. It consists of a diode-bridge rectifier powered by a single-phase AC supply at its input. An uncontrolled DC voltage is bred at the output of the rectifier. This uncontrolled DC voltage works as the input of non-isolated Zeta converter. This converter provides a controlled and regulated DC output voltage as well as the mains current is sinusoidal, which can form the improved power quality, PQ, standard. The major concerns of an EV battery charger is the presence of low AC ripple constant in charging current. The ripple current flow through the battery because of the huge capacitance in the battery circuit, and it taken care of the reliable battery operation. So it increases the internal temperature of the battery due to excess heat. Therefore large amount of ripple current is reduced life cycle of the battery. So it designing the AC-DC converter of battery charger to meet the permissible ripple current requirements of the battery with use of a non-isolated topology. A non-isolated Zeta converter is a fourth-order nonlinear system with regard to energy input and the same as SEN in the buck-boost converter and with regard to the output. A non-isolated Zeta converter modes are depending on inductance value, load resistance, and operating frequency. Here only continuous conductor current IL1. The analysis uses the following assumption. Semiconductors switching devices are considered to be ideal. Converter operating in continuous current mode. Line frequency ripple in the DC voltage is neglected. 3.1 Operation. Mode 1. The first mode is obtained when the switch is on and instantaneously, the diode D is off condition as shown in Fig. 3. During this period the current flow through the inductor L1 and L2 are drawn from the voltage source Vs. The capacitor C2 is charging condition. This mode is the charging mode. Mode 2. In this mode of operation starts when the switch is off condition and diode D is on position as shown in Fig. 3. In this mode of operation is the inductor L2 is transfer the stored energy into load R, battery. So the battery going to discharging mode.